Alright, let me go through it. I made this one multiple choice because a lot of the answers like come out in this form, and that's okay. Like that's how they'll write on the AP test too. They'll leave it in this like 2 month. They won't put the decimal really usually. They'll just put it like this. So I just want to like get used to doing that. So I don't really need to do U substitution in here because there's not a big limit. Like I heard a few people talking about like what's U and the chain rule. There is really no chain rule. Like if you wanted to say the little guy's x, because the point of chain rule is that we want to be able to take the derivative of the big guy, and then there's a little guy also that has its own derivative. But I can take the integral of sec tan. Remember, what's the integral of sec tan? It's sec, and then like your little guy's x, but what's the derivative of x? It's just 1. So like what I would do is look at it like this. I'm going to bring the 2 out. And then rewrite it as sec x tan x. And then I'll have a 2 outside of my integral. And then, like I said, what's the integral of sec tan? Is sec. So we get to there. So if it were like sec of 3x tan of 3x, that'd be U substitution. Or it could actually be like sec of ex, e to the x, tan of e to the x. We start to make this more and more complicated. Wow, that's really awkwardly small. So there's like the calculus part. Is that just that part up there? Questions on that part? And then I got to plug in, which is no picnic either. So I got 2 times sec of 0 minus sec of negative pi over 4. All these parentheses and brackets. And so first of all, what is secant? It's cosine flipped, right? So at 0 degrees, cosine's your x value. Your x value is 1. So what's that flipped over? It's still 1. Minus, and then sec of negative pi over 4. So you go backwards. So pi over 4 would be there. Negative pi over 4 is the same thing backwards. And actually cos is the same at those 2 spots because it's your x value. So what's your x value at negative pi over 4? Is the square root of 2 over 2. That's cosine. But what do I have to do with it? Flip it. So this becomes 2 over the square root of 2. And then if I distribute, like I'm kind of, now I'm looking at the answers and seeing like, okay, I gotta play their game and match up with whatever they play. Because part of me is like, am I gonna have to like get rid of the fractions? I'm not sure what I'm supposed to do yet. So I'm kind of looking at the answers for a guy. And I noticed they have like 2 terms. So I'm gonna distribute first. So that'd be 2 minus 4 over the square root of 2. And I'm still not there. I'm pretty sure it's A at this point. Because there's no 5 anywhere, really. I can't make a 5 out of like 2s and 4s. There's no 3. That seems a little bit like too simple. So I'm pretty sure it's A. Let's make sure we know how to get there. So how do I get rid of a root on the bottom? Like multiply by that same root, right? So now I'll have 2 minus, on top I'll have 4 root 2. And on the bottom, what's the square root of 2 times the square root of 2? It's 2, and then the 4 divided by 2 simplifies to be 2. I do end up with 2 root 2. There's a lot going on there. You gotta know how to integrate. Is it general? Is it not? You gotta know how to plug in. You gotta do unit circle. You gotta be able to like rationalize and reduce. So on the gateway, it's not gonna be multiple choice. So I would accept like that answer or anything below it. So I don't care if you put negative or radical at the bottom. I'm okay with that. Because remember the idea is if you can leave it, if all you have left have left here? Multiplication, subtraction, division. So I'm okay to leave it. You can't leave it and say like, oh, that's my answer. You figure out the trig, and I'm good. But once you get the trig done, and all that you have left is like simplifying, you're actually okay to stop there. But the only way you're gonna know you're right on this is to keep going and check. And you can get the decimal, I guess. Let's see. Question on that one anywhere? Let's try that one. Try two. So not all trig. There's weird powers, like fractional powers, trig, and E and LN. I am giving you a worksheet, but not yet. I asked. So is this U substitution? It's not. There's not a big guy, little guy. There's just regular power. So again, it's not U substitution because there's not like a big guy and a little guy. There's just an x to a power. That's power. So I'm going to just go straight to integrating it. Leave my negative 1 and 0 there. Add 1 to the power. So I have 4/3. Multiply by the reciprocal of the power, which is 3/4. So then over here, when I multiply 3/4 times 5, I actually have 15/4. So then that becomes 15/4 times plug in the top to the 4/3 minus plug in the bottom to the 4/3. And the 0 is nice because 0 to any power is just 0 times, so that just goes away. And then you have a negative here. So to work with this, the third root of, I got that bracket in the weird spot. So the third root of negative 1 is how you start this. So what number to the third power gives me negative 1? Negative 1. And then if I do negative 1 to the fourth power, because now it's an even number, where am I at? I'm at 1. And then 15/4 times 1 is 15/4. And that negative from up there is still there. So you end up with C. Is what? Oh, I don't know. We'll see. How many had that one? That's not as bad as the trick ones, right? What up? Like way away. Yeah, that's not gonna happen. Try that one. I had another trick one, but that was C10. So it was like the same trick one. Is this u substitution?
Yes.
What's big N? Okay, what's little N?
It's not. So it's just shouldn't it be the same thing as it is
The integral of 2e to the x is 2e to the x, right? It's not u substitution. Because you don't have like a big N. So if you want to say the big N is e, that's fine. Little guy is x, but then like what's the derivative of x? It's 1. So if the derivative of the little guy is 1, it's not really a little guy. Because the 1 is not going to like change it. If it was like e to the 2x, now your 2x has a derivative, so now you got to worry about it.
Right.
I'm saying you don't need u substitution. What'd you get, Caleb?
C.
C. I don't know how to do it. I can't really process it all in my head. Seems reasonable. It has to be a positive answer. Why? What's true about the graph of e to the x? It always goes up, and it's always above the axis, isn't it? So isn't the area always going to be positive since you're above the axis? Or is d the only positive number? Just because.
Yeah, I got this.
I don't think it's D.
I got C.
I think it's C, but I didn't do it yet, so I'm not sure.
Well, how about
Let's go through it. So you need u substitution if you have like two functions. But x by itself is not really a function, it's just like a variable. So e is a function because that's like doing something. But I don't have another function. I don't have another power. I don't have like a trig. It's just like e to the something. So you're not having to use u substitution. The two, you can do a couple things with it. You can just understand that it like just like carries through, or you can bring it out. Like if you rewrote it like this, I think people would have seen what's going on a little easier. And then you can just say, well, what's the integral of e to the x? E to the x. So you can go, okay, that's 2 times e to the x from negative 3 to 0, which is 2 times e to the 0 minus e to the negative third. You with me? What's e to the 0? 1. Anything to the 0 power is 1. What's e to the negative third? So I don't have to really know what it is, but when I'm looking through my answers, I realize that there's not a single negative exponent in any one of those answers. So I probably shouldn't have negative exponents in mine either, right? So how would I rewrite this so it doesn't have a negative exponent? It'd be 1 over e to the third, right? So I get that. And then I'm like, okay, well they don't have any like parentheses, so I probably should distribute. So I'll get 2 minus 2 over e to the third. Like 2 times 1 is 2. And then 2, this is really like 2 over 1. Times 1 over e to the third, so 2. And I still don't match up, but then I realize they put it into one fraction. So I should probably do the same thing. So I'm going to need a common denominator. So if I put an e to the third on the bottom there to make those match, I gotta put an e to the third on top also. Then I think you can start to see. So you do end up with C. Questions on what I'm doing there? Where'd you do this? Why'd you do this? I had C. Alright. Does that help though, Doug? If we had to use substitution? If there's literally anything else, like not anything else, if it's just a number, that doesn't count. But like cosine, x squared, it could be another e to the x. It could be automatic. Was there yet? So yeah, that's a good question. Where would I want you to stop on the gateway? I'm okay with that on the gateway. Like if there's an e to the zero, I'd want you to simplify because that's not just like multiplication, addition, subtraction, division. But from that point, it basically is. So. And I don't want you to like freak out about same thing as last time. If we're on the gateway and you get to here, and for whatever reason on that specific problem, it's not enough simplifying, I'll just tell you, like, hey, go back and like get rid of the negative exponents, bring it back up. Like I'm gonna be, I don't want the simplifying to be the issue. So if you haven't simplified it correctly, I'll tell you, give you a chance to fix it. Don't let that be your main concern. Wait, what? What happened? How do I go by? Oh boy.
Let's go.
Alright, try this one. Negative sec squared of x. Matthew, they changed that to v, but there's still negative 3 in it.
I got a feeling this answer is C.
How does that work out?
But all of our answers are consistent. I do think it's D. Yeah.
Doing it in my head, I think it's B. But that's not in my head. You make a lot of mistakes. Wait, that was you. For a second, I thought it was you. It didn't make sense. Was it you? That makes more sense.
Either one.
seriously. Let's see here. Come on, son. Line rack or sign over code. Red line is like over top. Yeah. Go.
Right, but like, what's that?
Remember when you showed people photos of the inside of my house? Yeah. And then you showed people like my bedroom. My bathroom. Yeah. Here's a live shot. Okay. So, do I need U substitution? So here's the question to ask yourself. Can I integrate that as it is, or do I need to alter it somehow? Can I integrate sec squared? I can. What if it was cos squared? Can I integrate that? That's not one of the things we memorized, right? So that would be a different ballgame. I would actually need to have like a sign out here, because that would make 2 the big guy, cos the little guy, and I would need to have the derivative of the little guy out here. So that's a different ballgame. We'll get there. But this, I can integrate the sec squared as it is. And it might be helpful to yank the constant out in front and rewrite it like this. And then it's like a little easier to tell, oh, I know how to integrate sec squared. So then it will be negative. The integral of sec squared is tan of x. Pi over 6 and pi over 4. So I gotta plug in. So it's gonna be tan of pi over 4 minus tan of pi over 6. So you could not stop there in the gateway because you have more left to do than just multiplication, addition, subtraction. I gotta figure out the tan of those things. So pi over 4 is 45. 45 is nice because y and x are the exact same. Divide those, so what's tan of 45? It's just 1, right? Tan of pi over 6 is a little more annoying. Pi over 6 is 30. The y value is 1/2. The x value is the square root of 3 over 2. So it's 1/2 divided by the square root of 3 over 2. That's your y over your x, or your sine over your cos. And then we don't divide fractions. We flip over the bottom and we multiply. So I'm not going to divide by the square root of 3 over 2. I'm going to multiply by 2 over the square root of 3. And I go straight across. So 1 times 2 is 2. 2 times the square root of 3 is 2 times the square root of 3. And then I can make my life a little easier. So what can I do with those 2's? So you could do that. And if you stop there on the gateway, I'm okay with that. But you can't stop there in this because you won't know if you're right or not. What if you don't what? So you have like -1 plus 1 over the square root of 3. You'll get the same answer. Yeah, those are both okay. But on the AP test, or on a multiple choice test, they don't stop where you want them to. They make you kind of figure out what they're doing, and it's not going to be one of these 2, but you got to figure out which one of these it is. So I actually like what Ben did better. Let's say I distributed the negative sign through, but then I need a common denominator. So I would need there to be a square root of 3 down here, so I can add them, and then I need a square root of 3 on top to match up with it. So I get negative square root of 3 plus 1 on over the square root of 3. So I'm not there yet, right? Like I'm now at the point where I'm like, I think I'm done, but they're like, screw you, no, you're not. But I could get to that answer if I multiplied everything by what? By the square root of 3. So if you multiply that by the square root of 3, you get negative 3. Multiply that by the square root of 3, you get square root of 3. And then that would be 3. So I think what they're doing is saying we don't want this radical on the bottom. Like multiplying everything by that. So there's kind of two levels to this. One level is like, can you get to here or here for the gateway? If you are taking the AP test, there's a whole other level. Can you get to like where there? And so for this worksheet, you got to get to here to check it. And I'm good with that because of the AP test, you have to get there because you got to be able to match up with whatever they're doing. How many have that one? Try that. Alright. This is your first. Gotcha. Welcome to school.
Thanks.
What the heck?
Hey. Killed it.
Yeah, it might be easier if you take that constant out first. It might not. Like everyone kind of views it differently. But not to it yet. So I think we'll just do like practice problems together, like the whole class today, and then tomorrow. That work?
Yeah.
Now you gotta figure out what side of it. Yeah. What is what? You're talking to me? You're talking to me, Caleb, and yourself, man. It gets so confusing. A lot of people think it's two. You know? I don't know how to do it. I'm just saying a lot of people have two. We need to get rid of it.
Is it?
Okay. Remember the drill. So I yanked that -2 out. I just think it makes it a lot cleaner. You can see what's going on a little better. And then the integral of sine is cos. So that sine gets confusing. The SIGN confuses some people. But remember the derivative of sine, like that doesn't start with a c, so the derivative is not negative. So the derivative of sine is cos, which means the integral of cos is sine. Then I got to plug in these two numbers. And when I went to plug them in, like my brain works in degrees. I think probably most people here, brain works in degrees better than radians. But you can do whatever you want. But negative pi over 2, I was like, okay, that's down there. That's 2 7. Like that's easier for me to process. And then negative pi is over here, so 180 is easier for me to process. And then sine's your y value. So what's my y value down there? At 270? -1. And what's my y value over there? 0. So if I work out that, and technically on the gateway you can stop there. But I think it's easy enough to go to the multiple choice and say, okay, that's 2. How many had 2? Alright. Getting better. Oh, no, yeah. Try that one. This sucks. That sucks. Are you on the bonus team? It's in the winter.
Yes.
Yeah, you could get the multi-sported.
It's not like I have to.
Yeah. I think it's 6 worse than the others.
Yeah. Just on secant. No, just secant.
It's not of the things you said. Oh, so far.
Oh wait. No, you can't. No.
Closer. Close-ish. The last rule is still in place. It's cotent. Well, it's negative.
Oh shit.
It's like the only one you can say.
Right.
So if I talk through the first part here, again, I like yanking out that constant because it's just kind of clarifies what's inside a little bit. The integral of cosecant squared is negative cotan. You gotta memorize that. And then I just replaced these with degrees. I stopped earlier than I did last time. It doesn't really matter. You can do it here too. Again, I just think in radians or degrees better than radians, which I think like you guys agree with that. Degrees are easier, right? If you think radians are easier, leave it in radians. And then cotan of 270 is what I got to figure out here. So negative something minus negative is plus, and then plus something. So cotan of 270. So cotan is tan is y divided by x, which means cotan is x divided by y. So what's the x value here? 0, and the y value is negative 1. 0 divided by negative 1. So that's a 0, which is really nice. Where? Okay. And then cotan of 225 I gotta figure out. So that's kind of a nice one too, because cotan is x divided by y, but they're both the same. So when you do x divided by y, what are you gonna get? It's just 1. So I essentially have 2 times 1. My answer ends up being 2. Do it where, so you have like negative 2 cotan of x in here. So then it would be negative 2 cotan of 270 minus negative 2 cotan 225. If I can make one recommendation that applies to most people's work I see, include more parentheses. It's very easy to get confused or disorganized without them. I think they're super helpful. I understand you can kind of get lazy. It's like, I don't need them. But I just think it's really helpful. So I take that for what it's worth. But I think the more parentheses you put to kind of clarify what's what is helpful. So again, cotan 270 is 0. So negative 2 times 0 just goes away. So it's 0 minus negative 2. And then this cotan part here is 1. So you end up with like 0 minus negative 2, which is still 2. What's up? 225 is here. So the x and the y value are both negative. So when you divide them.
I did.
Okay. Okay, this is the part where like 2/3 of the spread of leave, 1/5 of my class leaves. So tomorrow I'll give you a worksheet where you guys do those. Showing up to school.
I got negative 2 times 5 pi over 2.
Where are you at?
Is that not what it is? No. It's negative 3 pi over 4. Oh, I know. But
So you gotta take the cotan of negative 3 pi over 4.
oh.
So like if you think about